In this video, we're going to be taking a second look at this log that was previously submitted, and there's an issue in there where the copter is rolling out of turns. Ideally, the copter should be rolling in the same direction that it's yawing when you're turning, unless you're trying to do some kind of a crazy move. But in this case, the copter seems to be rolling out of the turn. And that is a common tuning issue that I've talked about in other videos where you may need to tweak your P and your I gains so that they're working properly together. But when the log was first submitted, I just kind of referenced one of those videos and said, "Here, take a look here." And the person who submitted it said, "No, no, no, that's not what's going on here." And in fact, it seems to be that the gyro is reading wrong. So let's take a closer look and see if that interpretation is correct. That would be pretty interesting if it was true. So I'm going to set up my logs here and my traces, and we'll take a look at the roll, and we'll take a look at yaw. And then I think I would also like to see RC command, so I can see what I always want to check and see what is being input. So if there's any sort of strange movements of the copter, I know whether it's the pilot doing something with the sticks or whether it's the PID loop doing something. And actually, I would actually like to put RC command on top. The top trace is always covered up by the little quad graphic and by the sticks overlay. So I always try and put something up on the top that isn't quite as important. We'll just do roll and yaw, and then we'll add roll and yaw PIDs as well. Okay, so we've got that up, and now we'll take a look at the turn, and we'll just watch it full speed first of all. And there you can see, in fact, the copter did roll out of the turn. Okay, right here. We'll go back and we'll watch it again. Right there, the copter's rolling out of the turn. So that definitely is no good. And let's just take a look next at RC command, and we'll see what the pilot was doing while that was all happening. So as we move forward here, we can see that roll and yaw are coordinated. I've mentioned this before, but I'll mention it again. Roll and yaw, when they're coordinated, their traces go opposite directions. So left yaw, the trace goes positive, and left roll, the trace goes negative. And that's always been a little confusing to me ever since I started using Blackbox. You would expect them to go to the same direction for a coordinated turn and the opposite direction for an uncoordinated turn. That's not the case. So when you see yaw go one way and roll go the other way, that is a coordinated turn. So we begin this coordinated turn, and let's just play this at a very slow speed. Coordinating. Okay, so now roll has centered, and yaw is continuing. And that alone is potentially going to explain the issue. Now you're pushing, you're counteracting that perceived right roll. Now you're pushing left again because you saw the copter rolling right. But I think the copter, my initial impression is that the copter started rolling right because you centered the roll stick. If you are flying with up tilt on your camera, this may be an effect that you'll see. So it may be helpful. I'm not going to be able to explain this without a model, and so I'm not going to set up the camera just to record a model. But if you have up tilt in your camera, you can hold your copter in your hands and you can practice this, or you can just experiment with it, through your goggles. If you input yaw, let's say you're flying forward, so the copter is pitched forward, but the horizon looks level because you have up tilt in the camera, right? But the copter is actually pitched forward. If you then yaw to the left without inputting any roll, let's say you're pitched forward 45 degrees and you do a 90-degree left yaw, you will now be rolled right 45 degrees because the copter will yaw about its own z-axis, if you will. So what happens if you yaw without rolling, if you have camera up tilt, or if you don't have camera up tilt and you're just flying forward, anytime the copter is not perfectly flat, basically. So it's most common when you have up tilt, but it could happen if you don't have up tilt. Anytime you yaw without rolling and the copter is not perfectly flat, you will get a perceived roll input. Um, and so yaw left, the horizon will appear to roll to the right. Let me just double check that. Okay, yes, I've double checked that. Yeah, if you yaw left without inputting any roll, the horizon will appear to roll to the right, and you'll need to input right roll to counteract that. And likewise, if you yaw right, the horizon will appear to roll to the left. So I think what we see happening here is that you begin a coordinated turn with both yaw and roll input, but then you stop coordinating the turn here, and the horizon should begin to appear to roll to the right. And sure enough, it does. So I think this is a piloting issue more than a tuning issue. Anytime you are not flat and level and you yaw without rolling, you will get a perceived roll input because the copter is not yawing. It's not yawing about, the copter doesn't yaw around an axis perpendicular to the ground. It yaws about an axis perpendicular to the flight control board. So if you're pitched and you yaw, you will also be rolling. Okay, enough said about that. The other question that we need to address though is, are the gyros reading correctly? And I'm sure that they are. Like, it would be a huge bug if they weren't, but let's take a look anyway. So now I've got the graph set up with just RC command roll and gyro roll, and we're just going to focus on that, and I'm going to play it forward at 15% speed. So here you're inputting left roll, and the gyro is negative, indicating left roll. RC command and the gyro always indicate the same direction. In other words, if RC command is negative and gyro is negative, the copter is moving in the direction you're commanding. If RC command is negative and gyro is positive, the copter is moving the opposite direction from what you're commanding. Again, I don't want this to get too confusing because I've talked about how yaw and roll go the opposite direction in terms of roll is left is positive, right is negative, or vice versa. But RC command and the gyro for a given axis, like roll, pitch, or yaw, will always agree. So here we've got left roll being commanded, and we've got left roll occurring. Okay, copter is rolling at a continuous rate, and then as you center the stick here, roll ceases. And again, that's about what we want to see. When if the PID algorithm is doing its job, when the stick is centered, your angular rate will be 0. Your angular rate is pretty close to 0 here. There's a little bit of a blip on the stick here. Fine. Angular rate pretty close to 0. The gyro is close to 0. RC command is close to 0. So we can see that they're roughly tracking each other pretty well. Here, you begin to input left roll, and again the gyro goes negative as it should. And as the stick comes back to center, the gyro roughly centers. So we can see that the gyro is roughly tracking the stick. Everything seems to be working properly. Okay. Now, I do agree that if you look at the video, it looks like something may be going wrong. Let's take a look, and we'll find the spot where it is. So here, it certainly looks like the copter is rolling to the right, but the gyro is showing left roll, right? Is that incorrect? And the answer is no, it's not incorrect. You have to realize that there's two things going on here. There is the change in the perception of the level of the horizon. In other words, the horizon appears to be rolling right or left because you're yawing and because the copter is not flat. So again, if the copter is pitched forward and you yaw left, the horizon will appear to roll to the right, but in fact the gyro will report 0 angular rate because on the roll axis because you haven't actually rolled the copter at all. You've yawed the copter, and a combination of yaw and pitch results in an effect of a change in roll without actually creating any angular change on the roll axis. And if that's confusing to you, think about doing like an Immelman. Right? In an Immelman, if I know my aerobatics correctly, which I may not, I believe that's the name for the move, where you do a 180 roll, so you're inverted, and then you do a 180 pitch. So now you're facing back the direction you were facing, right? So you flip over on your back, invert it, and then you pitch over so you're right side up again, and now you're right side up facing the opposite direction you were going. Well, you just did a 180 yaw, didn't you? But you never actually did any motion on the yaw axis. The yaw gyro still showed 0. So a move on 2 axes can sum up to create a move on the 3rd axis without ever actually resulting in the gyro going off 0. So here is a case in your video where it appears that you are rolling to the right, but the roll gyro actually shows a little bit of left roll. And the reason for that is that because you're yawing and you're pitching at the same time, right? You're actually, the horizon is rolling to the right while the copter's roll gyro is actually reporting slightly left roll. So the bottom line is that nothing is incorrect here. If you want to assess your tune, the effectiveness of your tune, and whether the PID algorithm is doing the right thing, you have to compare RC command to the gyro. And if RC command and the gyro are roughly tracking each other, then the PID algorithm is basically doing the right thing. All right. So yeah, the takeaway from this video is that you didn't coordinate your turn quite well enough. So you got to work on that on your sticks. That's a pilot training issue, not a tuning issue. Your tune actually looks fairly decent in terms of what roll is doing. I didn't look at yaw super close, but yeah, I think this is more an issue of what you're doing with your right stick, or your roll stick, than anything else. Okay, hope that was helpful, and happy flying.